So what is the return on this bond? Well, let's start with the definition of what expected return is. It is the expected payoff that we get from this bond minus its price divided by its price. We already know the price of this bond, which is $96. So what's left to find is the expected payoff that we get from investing into this bond. Well, the expected payoff can be found as the probability of the first state, which is 0.3, times the payoff that we get from this bond in this first state, $100, plus the probability of the second state, which is 0.4, times the payoff that we get from this bond in the second state, which is $100, plus the probability of the third state, which is 0.3, multiplied by the payoff that we get from this bond in the third state, which is $100. So adding this up gives us $100. And it's very intuitive when the expected payoff on this bond is $100 because in each of the three states, we get $100. So no matter which state is realized, we get exactly $100. So therefore, the expected payoff is just 100. So now we know the expected payoff, we know the price of the bond, so we put them back into the return equation, and this gives us $100 minus $96 divided by $96, and that equals 4.17%. Note that this return of 4.17% is guaranteed. Why? Because there is no uncertainty in what payoff we will get from holding this bond next period. We're going to get $100 regardless of which state of nature is realized. So in this sense, this return is risk-free. Note that in the question, we didn't ask what is the expected return. We just asked what is the return on the bond. Because again, this return is guaranteed to us. Now, what is the expected return on the stock? Well, again, by definition, the expected return is the expected payoff minus the price of the stock divided by the price of the stock. Well, we need to find the expected payoff from investing into the stock. Well, it's going to be the probability of the first state, 0.3, times the payoff that we get from the stock in the first state, 120, plus probability of the second state, 0.4, multiplied by the payoff that we get in the second state, $75, plus the probability of the third state, which is 0.3, times the payoff that we get from the stock in this third state, $130. So this gives us $105, which is the expected payoff that we get from investing into the stock. Well, the expected return is then 105 minus 80, which is current price of the stock, divided by 80, which gives us 31.25%. So therefore, the expected return from investing into the stock is 31.25%. In this problem, we're given state prices, and we're asked to find the price of the bond. To find the price of the bond, we have to multiply the payoffs that we get from this bond by their state prices. We have only two states in this particular case. So therefore, the price of the bond equals to the payoff that we get in the first state, multiplied by the price of that state, plus the payoff that we get in the second state, times the price of that second state. It's $100 times 0.35 plus $100 times 55. That gives us $90. So the price of this bond today is $90. Notice, this is a riskless bond. So one shortcut that we can take here is just simply to add up state prices, 0.35 plus 0.55, that gives us 0.9, and multiply it by the payoff that we get from this bond, $100 in both states. So that would give us $90. The second question asks, what is the price of the stock today? To find the price of the stock, we again multiply the payoff that we get from the stock in the first state by the state price of the first state, plus the payoff that we get from the stock in the second state times the price of the second state. It's 150 multiplied by 0.35 plus $40 that we get from the stock in the second state times 0.55. This gives us $74.50. So the price of the stock today is $74.50. In this question, we're given a state space model that has 3 states and 3 assets currently traded in the market. Asset 1 is a riskless bond with the current price of $95. It pays $100 in each of the 3 states.
Asset 2 is a stock. Its current price is $150, and it pays $250 in state 1, nothing in state 2, and $500 in state 3. And finally, asset number 3 is another stock that is currently priced and traded at $100, and it pays $0 in states 1 and 2, and it pays $500 in the state 3. The question is, what are the state prices? To answer this question, let's start by writing down the pricing equation that connects the payoff that we get from an asset with the state prices. So recall that in question 2, we're working with the following equation. So the price of any asset equals to the payoff that asset pays in the first state multiplied by the state price of that state. And similarly, what that asset pays in the second state times the price of that second state, plus here we have 3 states in total, so we have the third state as well. So now we can write down the prices of each of our 3 assets as the function of the state prices and what these assets pay in each of the states. So let's start with the riskless bond. So we get 95 equals to phi 1 multiplied by 100 plus phi 2 multiplied by 100 plus phi 3 multiplied by 100. Now for the second asset, or for our first stock, we can write down the following equation. So its current price is 150 and it pays 250 in the first state, so it's phi 1 multiplied by 250. Doesn't pay anything in the second state, so it's going to be phi 2 times 0, which is 0, plus phi 3, and I can put 0 here, phi 3 times 500. And finally, for the asset number 3, or the second stock, we can write down the pricing equation for that stock, which is 100 equals to phi 3 multiplied by 500. And so the remaining phi 1 times 0 is 0, and phi 2 times 0 is 0 as well. So now we have this system of equations with 3 unknowns. It's a very easy system of equations to solve. So from the last equation, we get phi 3 that equals 0.2. We can plug this phi 3 into the second equation, and by solving that equation, you could verify that phi 1 would equal to 0.2 as well. And finally, we can plug phi 3 and phi 1 into equation 1 and solve that equation for phi 2. And so if we do that, we find that phi 2, and I will write it down here. So phi 2 would equal 0.55. So altogether, we get that the state prices in this case equal to, so phi 1 equals to 0.2, phi 2 equals 0.55, and phi 3 equals 0.2 as well. So this is the set of the state prices in this state space model. If we were to use the state prices to price these assets again, given their payoffs, the way we've priced assets in question 2, we would have found that each of these assets, so the riskless bond, its price would be $95, the price of stock 1 would be $150, and the price of stock 2 would be $100. So altogether, this question teaches you how to find the state prices from the given prices of traded assets.
In this question, we're given a state space model that consists of 3 states. All 3 states are equally likely. The first question asks us to find the price and expected return on asset X that pays off $100 in the first state, $80 in the second state, and $100 in the third state. So let's start with the price of this asset first. So the price would equal to the payoff that we get from this asset in state number 1, multiplied by the state price of the first state, plus the payoff that we get in the second state multiplied by the price of the second state plus the payoff that we get in the third state multiplied by the price of the third state. This gives us $100 times 0.2 plus $80 times 0.55 plus $100 times 0.2 and gives us $84. So the price of this asset X right now is $84. Now the second part of the questions asks us to find the expected return. To find the expected return, the first thing we need to find is the expected payoff that we are expecting to get from this asset. Let's find it. So to find the expected payoff, we are multiplying the payoffs that we get in each of the states by their probabilities. In this case, all three states are equally likely, so probability of the first state is 1/3, second state is 1/3 as well, and the third state is 1/3 as well. So therefore, the expected payoff equals to $100 multiplied by 1/3 plus $80 multiplied by 1/3 plus $100 multiplied by 1/3. This gives us $93.33. Now, to find the expected return, we're taking this expected payoff, $93.33, minus the current price of the asset divided by the current price of this asset, which is $84. So 93.33 minus 84 divided by 84, this gives us 11.11%. So the expected return on this asset X is 11.11%. The second question asks us to find the price and expected return of asset Y. Asset Y pays off $100 in the first state, $100 in the second state, and $80 in the third state. Let's start with the price. The price of asset Y equals to the payoff that we get from this asset in the first state, $100, times the price of the first state, 0.2, plus the payoff that we get in the second state, also 100, times the price of the second state, 0.55, plus $80 that we get in the third state, times the price of the third state, 0.2. This gives us the price of this asset, $91. Now, to find the expected return, we again start with the expected payoff that we get on this asset. The expected payoff would equal to the payoffs that we get in each of the three states times the probabilities of each of the three states. Because each of the three states are equally likely, the probabilities again are 1/3. So putting this all together gives us $93.33. Now notice that the expected payoff on asset Y, $93.33, is exactly the same as the payoff that we computed on asset X in part A. This is due to the fact that the payoffs from assets X and Y are similar in the sense that both of them give us $100 in the first state, but in the second state, asset X pays off $80 while Y pays off $100, and in the third state, asset X pays off $100 while Y pays off $80. Because of the symmetry and because of the fact that each of these states are equally likely and occur with likelihood 1/3, the expected payoff of asset X is the same as the expected payoff of asset Y. So finally, to find the expected return on asset Y, we're taking the expected payoff, $93.33, we're subtracting the price of asset Y, which is $91, and divided it by the price of this asset Y, $91. This gives us 2.56%. So the expected return on asset Y is 2.56%. Let's look at state prices again. The price of state 2 is 0.55, and the price of states 1 and 3 is just 0.2. So the price of state 2 is much higher than the price of states 1 and 3. This means investors are willing to pay a higher price to receive $1 in state 2. Put differently, investors value money in state 2 more than they do in states 1 and 3. State 2, for example, can be an economic recession. In recessions, many economic agents may receive lower income. For example, workers may receive lower wages, firms may earn lower profits. Therefore, a security that pays money in bad states of the world typically has higher prices because money in bad states is more valuable. Assets X and Y pay off the same amount in state 1. However, asset X pays off $80 in state 2 and $100 in state 3, while asset Y pays off $100 in state 2 and only $80 in state 3. So therefore, Y pays $20 more in the bad state, while X pays off $20 more in good state. So intuitively, this implies that the price of Y should be higher than the price of X. And because asset Y pays more when money is more valuable, investors are willing to accept a lower rate of return from investing in asset Y compared to asset X. Indeed, as we have seen above, the expected return on asset X is 11.11%, while on asset Y, it is only 2.56%. In this question, we're given two options. We're offered $10,000 today or $11,500 in 1 year from now. To compare the two options, we have to compare them at one point in time. The easiest way to do that is to compare them as of now. What is the present value of option 1 and what is the present value of option 2? So the present value of option 1 is trivially just the value that we offer today, is $10,000. Now the present value of option 2, we have to find what is the present value of $11,500 that we are receiving 1 year from today as of now. And for that, we're given an interest rate of 8%. So the present value of this payment that we receive 1 year from now is $10,648. So the present value of the second option is greater than the present value of the first option, so therefore we should prefer the second option. Let's try to understand why in this question we're preferring option 2 to option 1. Let's look at this interest rate of 8%. This interest rate represents our opportunity cost of capital, which means what rate of return we can earn on investments that have similar risk as our sister's promise. So let's consider the following hypothetical scenario. Let's take $10,000 from our sister today and invest it in one of these assets that have similar risk and therefore gives us expected rate of return of 8%. Then the future value of this investment will be $10,000 that we invest today and 8% rate that we earn at the end of this year, which gives us $10,000 and $800. So in this hypothetical scenario, if we take $10,000 today, at the end of the year we're going to get $10,800, which is lower than what we're going to get from our sister, which is $11,500. And because these two options have the same risk, and one gives us more money than the other one, we should be preferring the second option. In part B of this question, we asked to pick between two options. Option 1, which is the same, it gives us $10,000 today. And option 2 gives us $18,000 in 10 years. To choose between these two options, we're going to compare their value at one point in time. We're going to compare their value at present. The present value of option 1 is just $10,000. The present value of option 2 is $18,000 received 10 years from now, discounted to present at 8% rate, which gives us $8,337. Since the present value of option 1 is greater than the present value of option 2, in this case we prefer to take $10,000 right now as opposed to waiting 10 years and receiving $18,000. To develop intuition, let's look at this problem from a different angle. Let's take this $10,000 and invest it in an asset that has similar risk that our sisters promise and therefore offers the same 8% rate of return. If we do so, in the future we will get $10,000 multiplied by 1 plus 8% raised to the power of 10, which gives us $21,590. So the future value of $10,000 invested at 8% for 10 years is $21,590. This is a higher amount than what we would receive from our sister in 10 years, $18,000. So therefore, we are better off taking $10,000 today and investing it at 8% rate and receiving $21,590 10 years from today. What is the average annual rate of return that we earned on this purchase? Well, let us denote by X the purchase price of this apartment that we paid for it 20 years ago. And by 3X its present value, because it's tripled since the time we purchased it. To help us think in terms of present and future value in this particular problem, let's shift the timeline 20 years to present and denote the starting point by t equal to 0 and this ending point by t equal to 20. Then x times 1 plus r raised to the power 20 would be the future value of this x in 20 years from now, and it has to equal to its actual future value right now, which is 3x. Now, the only thing we have to do here is to solve this equation for r. Well, x is of course irrelevant here, so it cancels out from this equation. And then we're left with 1 plus r equal to 3 raised to the power 1 over 20. Solving this equation gives us the interest rate of 5.65%. So the answer to this question is that the average annual rate of return that we earned on this purchase is 5.65%. What will happen if we invested the initial amount X into the stock market, and the stock market during this time period on average produced 10.2% annual return? Well, the future value of this X invested at 10.2% for 20 years would equal to X times 1 plus 10.2% raised to the power 20, and that would equal to 7X. Therefore, the initial amount of X would grow to 7x over this 20-year time period. So questions A and B give us the following information. If we invest X at 5.65% annual rate of return over 20 years, our wealth would grow 3 times. But if we invested at 10.2% annual return, our wealth would grow 7 times. So therefore, relatively small differences in annual interest rates may imply large differences in wealth over long time periods. So part C of this question asks us, how much of the wealth growth in B is due to return earned on previous return? Well, to answer this question, let's first compute the total return that we would earn just on the principal amount that we invested. The annual return on the principal amount is just 10.2% times X. And since we're earning this over a 20-year period, this would be just 20 times 10.2 times X. So our wealth would grow just 2 times if we were earning return just on the principal amount invested. But in B, we computed that our wealth grows 7 times, so 7x. So the difference between this 2x and 7x is the return that we earn on previously earned return. And in this case, it's very clear to see that most of our wealth that we are generating on our investment is due to return that we are earning on previously earned return. What is your expected rental revenue next year in real terms? Well, the current revenue they just recorded for this year that just passed is $650,000. Next year, your real revenue, or revenue in real terms, is the current revenue multiplied by 1 plus the growth rate. Notice that this growth rate is actually the real growth rate. And so in our cases, then it's $650,000, the current revenue, multiplied by 1 plus 3%, which is our real growth rate, which gives us $669,500. The next question asks, what is the present value of your real rental revenue that you expect to receive next year? To find the present value of real revenue that we expect to get next year, we have to discount it to present at the real discount rate. Applied to our case, this is $669,500, which is our real revenue that we'll get next year, discounted to present at the 6% real discount rate, which gives us $631,604. Question C. What is your expected rental revenue next year in nominal terms? Well, nominal revenue in year 1 equals to the current revenue multiplied by 1 plus nominal growth rate. But the question does not give us nominal growth rate directly, so we have to compute it. 1 plus nominal growth rate equals to 1 plus real growth rate multiplied by the rate of inflation. So we can use this equation to plug it into here. And therefore, the nominal revenue in year 1 is going to be equal to revenue now multiplied by 1 plus real growth rate times 1 plus the rate of inflation. Plugging in the numbers, we get $750,000 multiplied by 1 plus 3% multiplied by 1 plus 2.5%, which gives us $686,237.50. Question D. What is the present value and nominal rental revenue next year? The present value would equal to the nominal revenue that you receive in year 1, discounted to present at the nominal discount rate. Now, the question does not give us directly the nominal discount rate, so we have to find it. To find the nominal discount rate, we use the following equation. 1 plus the nominal discount rate would equal to 1 plus real discount rate multiplied by 1 plus the rate of inflation. Plugging this equation into here, we get nominal revenue in year 1 divided by 1 plus real discount rate multiplied by 1 plus rate of inflation, which gives us $686,237.50 divided by 1 plus 6%, which is the real discount rate, multiplied by 1 plus 2.5%, which is the rate of inflation, which gives us $631,604. Now notice, the present value that we get in this question is exactly the same as we've gotten in part B of this question. The present value is, of course, should not be affected whether we're dealing with nominal or real units. If we're discounting nominal revenue at the nominal discount rate and real revenue at the real discount rate, we should be getting exactly the same answer. If we don't, it means we have made a mistake somewhere.
Now, suppose that a real annual growth rate of 3% will continue over the next 4 years. The inflation is also expected to remain at 2.5% over the next 4 years. Assume that the appropriate real discount rate is 3%. What is your expected rental revenue in year 1, 2, 3, and 4 in real terms? Let us solve this question. We already found what is real revenue in year 1, which is our current revenue, $650,000, multiplied by 1 plus real growth rate, which is 3%, which gives us $669,500. Now, to find real revenue in the year 2, we're taking the current revenue in year 0, and we are multiplying it by 1 plus real growth rate GR squared, because this revenue grows at this rate GR for 2 years. So this is $650,000 multiplied by 1 plus 3% squared, which gives me $689,585. Similarly, real revenue in year 3 equals current revenue multiplied by 1 plus GR raised to the power 3, which is $650,000 multiplied by 1 plus 3% raised to the power 3, which gives us $710,272.55. Finally, extending this logic all the way to year 4, we get current revenue in year 0 multiplied by 1 plus real growth rate raised to the power of 4, which again equals to $650,000 multiplied by 1 plus 3% raised to the power of 4, which gives me $731,580.73. So altogether, these numbers give us real revenue in years 1, 2, 3, and 4. Next, let us find the present value of your real rental revenue over the next 4 years. The present value would equal to the real revenue that we receive in each of the 4 years discounted to present at the real discount rate. So real revenue in year 1 divided by 1 plus real discount rate, then real revenue in year 2 discounted to present again at the real discount rate. So here, of course, we have to raise this into power 2 because this revenue occurs in year 2. So therefore, this is the appropriate way to find the present value of that exact real revenue that we get in year 2. Then real revenue in year 3 divided by 1 plus real discount rate raised to the power 3. And finally, real revenue in year 4 divided again by 1 plus R, that's real discount rate raised to the power of 4. So putting this together, we get $669,500 divided by 1 plus 6% plus $689,585 divided by 1 plus 6% squared plus $710,272.55 divided by 1 plus 6% raised to the power 3. And the final real revenue in year 4, which is $731,580.73 divided by 1 plus 6% raised to the power of 4. Altogether, this gives us the present value of $2,421,171. So the present value of your rental revenue that they expect to receive over the next 4 years is $2.4 million. In this question, we asked, what is our expected rental revenue in year 1, 2, 3, and 4 in nominal terms? Recall that our current revenue in year 0 is $650,000. Then the nominal revenue in year 1 equals to the current revenue multiplied by 1 plus nominal growth rate. Now, recall that the nominal growth rate equals to and can be found from the following equation. So 1 plus nominal growth rate equals to 1 plus real growth rate multiplied by 1 plus the rate of inflation. Recall that the nominal growth rate equals to 3%, and inflation in this question equals to 2.5%. So this gives me 1.05575. And from this, I get the nominal growth rate of 5.575%. And now, this is the nominal growth rate that we can use to find nominal revenue in years 1, 2, 3, and 4. In year 1, nominal revenue would equal to $650 multiplied by 1 plus 5.575%, and this equals to $686,237.50. This number is the same as the one we found in part C of this question above. Now, continuing this logic, nominal revenue in year 2 is going to be current revenue multiplied by 1 plus nominal growth rate squared, again, because we received this revenue in year 2, and therefore it grows for 2 years at this growth rate GN. And this equals $650,000 multiplied by 1 plus 5.575% squared. This equals to $724,495.24. Nominal revenue in year 3 equals to current revenue multiplied by 1 plus nominal growth rate raised to the power 3, which again equals 650 multiplied by our nominal growth rate raised to the power 3, and this equals to $764,885.85. So finally, nominal revenue in year 4 would equal to the current revenue multiplied by 1 plus nominal growth rate raised to the power 4, and this equals to, again, 650 multiplied by 1 plus 5.575% raised to the power 4 now, and this equals to $807,528.24. So these numbers together give us nominal revenue that we expect to receive from renting out our property in years 1, 2, 3, and 4. The last part of this question asks us to find the present value of our nominal rental revenue over the next 4 years. Let us start this question by finding the nominal discount rate, which we will have to use to discount the nominal rental revenue back to present. We have already done this in part D of this question. So let me remind you. 1 plus nominal discount rate equals to 1 plus real discount rate multiplied by 1 plus the rate of inflation. Recall that the real discount rate is 6% and the rate of inflation is 2.5%. Multiplying these two quantities gives us 1.0865, and therefore from this equation we obtain that the nominal discount rate equals to 8.65%. Now we can find the present value of our nominal rental revenue. Let's start by writing down what this present value should be. Let me write it down in a more compact way. So it's the sum of all nominal revenue in every year I, where I is going to go from 1 to 4, discounted to present by using the nominal discount rate. So 1 plus R nominal raised to the power I. And so now we can expand this and we can use the nominal revenue for every year 1, 2, 3, and 4 that we found in the previous part of this question. So the nominal revenue in year 1 is 686, 237.50. We're discounting this to present at 8.65%, plus the second nominal revenue, which is 724,495 and 24 cents. We're dividing it by 1 plus our nominal discount rate, 8.65%, raised to the power 2, again because this revenue occurs in year 2, plus continuing. Nominal revenue in year 3 is 764,885.85, divided by 1 plus 8.65%, raised to the power 3. Plus the final nominal rental revenue is 807,528.24, divided by 1 plus 8.65%, raised to the power 4. Now, adding this all together gives us $2,421,171. Notice that this value equals exactly the same present value that we found in part F of this question. And this is the key lesson of this exercise, is that the present value, either you're operating in nominal terms or in real terms, should equal. If it doesn't, you have made a mistake somewhere along the way.